all about right triangles. So looking at the triangle ABC in question number 2, we're asking to find a ratio, which is a fraction, and in this fraction we want the side opposite over the side that's the hypotenuse. And we're going to be using angle A as my reference angle. So let me place a little mark here at angle A. Here's my reference angle. So if I'm looking for the side that is opposite, that would be the side whose length is 6. And the hypotenuse, always the longest side, would be the side that is 10. So we want to write the answer as a fraction in simplest form. So the opposite side to the hypotenuse, 6 over 10, and that reduces to 3/5. In number 4, we're again using angle A as the reference angle. In this side, I'm looking for the side that's adjacent. So this would be my adjacent side. And once again, the hypotenuse, always the longest side, or the side opposite the right angle. And as a fraction in simplest form, the adjacent side 20 to the hypotenuse 25, and those can both be reduced to 4/5. In number 6, we're again looking at angle A as our reference angle, and we're looking for 3 ratios. First, the opposite to the hypotenuse, then the adjacent to the hypotenuse, and the opposite to the adjacent. So let's go ahead and label our sides. The side would be the opposite, the side is the adjacent, and this side is the hypotenuse. So opposite over hypotenuse. And let's see, thinking of something that goes into both 18 and 30 evenly, I'm going to go with 6. All right. The adjacent to the hypotenuse is 24 to 30. And the opposite to the adjacent. Number 8, we're looking at the ratio opposite to hypotenuse. And again, we're using reference angle A. Anytime I see a triangle inside of another triangle, I always draw the triangle separately. So I'm going to begin with triangle ABC. And in triangle ABC, I have 3 lengths of 3, 4, and 5. In triangle ADE, segment DE is 6, segment AE is 8, when I put 4 plus 4 together, and segment AD is 10, adding 5 plus 5. So I'm looking at reference angle A for each of these triangles, and I'm looking for the opposite side to the hypotenuse. So in triangle ABC, the opposite side is 3, and the hypotenuse is 5. In triangle ADE, the opposite side to angle A is 6, to the hypotenuse 10, which also reduces to 3 to 5. some review questions at the end of this section. One is reminding us of the relationships in a 45, 45, 90 triangle. And if both legs are 14, the hypotenuse is always radical 2 times the leg. So the length of the hypotenuse is equal to 14 radical 2. And in number 12, we have a proof in trying to determine that angle R is congruent to angle U. The first thing I need to prove is that triangle RSV is congruent to triangle UTV. So before I can prove that the parts that correspond are congruent, I have to first prove that the triangles are congruent. So let's take a look at what we have in the given. Segment RS is perpendicular to ST. So if we have perpendicular segments, what we know is perpendicular lines form right angles. By the same token, segment TU is perpendicular to ST. So we have another pair of congruent angles, or we have one pair of congruent angles. So I'm going to write down an A for a pair of congruent angles. B is the midpoint of segment ST. All right, let's highlight segment ST. So here's the segment in reference, and B is the midpoint of that segment. So what that means is that these two lengths, SB and BT, are congruent to each other since B is the midpoint. Now that's all that's in the given. Oops. And so now I have a pair of sides that are congruent. So I need one more thing to prove that the two triangles are congruent. And what I notice is that we have a pair of vertical angles right here. And so I have another pair of angles. So yes, we have congruent triangles by angle, side, angle. Now that the triangles are congruent, we can say that angle R and angle U are congruent since they are corresponding parts. And so let's write this up in our proof. pair of congruent sides. VAT stands for vertical angle theorem, vertical angles. And what we know about vertical angles is vertical angles are congruent to each other. All right, so now I have my last pair of congruent angles. So now that I've proven that the triangles are congruent, I can now conclude that angle R is congruent to angle U. Angle R and angle U are corresponding parts which belong to congruent triangles, therefore they are also congruent. Here we have another proof. Again, we're going to be proving that angle W is congruent to angle Z. In order to do that, I first need to prove that these two triangles are congruent to each other. So let's take a look at the given. Segment WO is congruent to segment ZO. Segment XO is congruent to segment YO. So far I have one pair of sides and a second pair of sides. In addition, notice that we have a pair of vertical angles. So we're going to say now, in addition, I have a pair of angles and two pair of congruent sides. Takes care of these two. And once again, we're going to use the vertical angle theorem, and that takes care of the pair of angles. So now we can conclude that triangle WOX is congruent to triangle ZOY. And that is by side angle side. So what we notice is the angle, the two vertical angles, are sandwiched in between or included between the two congruent sides. So we can now say that angle W is congruent to angle C. And if we look at the drawing, angle W and angle C are corresponding parts, and they belong to congruent triangles. Therefore, they are also congruent.